Now you can use the slope formula, or you can just find the rise over the run. Because you have the graph, I would just do rise over run. Like you're going up 70, right 2. So your slope is 70 over 2 or 35, like that. So now we've got thing one, y equals 35x plus b. And we're more comfortable working with y and x than pb and big B. So go with this for now. We're going to back substitute those at the end. And then you choose one point or the other. Doesn't matter which one for x and y, and we're going to solve for b. So I'm going to use this point here because it's easier for me. So 0 is y, 35 times 4 plus b. So that's 140 plus b, 0 equals. So b equals negative 140. And that goes back here. So you're like, all right, I'm done. I got the right answer. Well, kind of, because you really want it to be in terms of the letters they use. So you map it back at the end to the letters that they use. So instead of y, you're going to use PB. Instead of x, you're going to use b, like that.
Gotcha. Okay.
So it's more of deception. It's not really a difficult problem. It's a confusing problem, if anything.
Gotcha.
What next? Where should we go to next?
All right. Okay. So, yeah. Okay. So I guess question number 22: use similar triangles to find A and B. So I understand this in theory, I guess, but for some reason I've been struggling to get the answers correct. So
yeah. So here, they're not quite right in the language that they're using. These are considered special triangles. And there's two special triangles. There's a 45, 45, 90 and a 30, 60, 90. And you learn more about these, or I guess you're in Algebra 2, you would have learned these in geometry. So in a 30, 60, 90 triangle, there is what I call the reference triangle, okay? And the reference triangle has a short leg, a long leg, and a hypotenuse. And if you're given the short leg, you automatically know the hypotenuse is double that. And then the long leg is x square root 3. So it's expected that you know this to be able to answer this question. Okay, now what you have to do is reorient your triangle or the reference triangle to match. So the 30 is up here, the 11 is here, A is here, and B is here. Are you comfortable with how I rotated this triangle to make this one?
Yes.
Okay, now the short leg is across from the 30. So in your problem, A is the short leg. B is the long leg because it matches with that, and then 11 is the hypotenuse. So this is the key here. You set the known side, which in your problem is 11, equal to the reference side, which is 2x.
Okay.
Solve for x here. So x is 11 divided by 2, like that.
And
then from there, you use the reference triangle to solve for the other side. So A is x. Do you see that from the left one? A is exactly x. So A is 11 over 2.
Okay. And then, so yeah, A is just 11 over 2. Gotcha.
B is the x root 3 side. So you need an x value. Well, thank goodness you've got it here. It's 11 over 2 root 3.
Okay.
So you have to know the reference triangle.
Yeah.
All right. And it's there's another one for 45, 45, 90 you would need for something like that. So
that helps that helps to think of it as in instead of, what they say 1, 2, and then square root of 3 for the sides, instead of think of it as an x, 2x, and then
exactly
x square root of 3. That helps a lot.
Yeah. And the words also help, like double the short leg, times square root of 3 short leg. Those sometimes the words mean more than the variables. Now, one of the things that I can do, and I'll just jump in and say this now, is like if you're like, hey Matthew, like I understood this one, but could you give me one like it? We can always do a problem like the one you just did. Now I know these are 30 problems. You've got you've got to do for your assignment, but I can always give you one like it if needed. So,
All right.
let me know where you want to go next. I'm happy to
Okay.
work on whatever for you for today.
Okay, so then I guess um, two problems which are similar but I've been struggling somewhat with. I've been getting better at them, but 18 and 19, specifically probably 19. So right, 4R minus 4U in polar form. So that's, and I guess this goes back to the whole concept of sine, cosines, and tangents. I just always mix up which ones are which and that sort of thing. So
Well, in full disclosure, I don't remember what this is because it only comes in Saxon books.
okay,
So I got to look here. R and
Gotcha.
U. Do you remember what R stands for? Is it this is not a standard
Yeah,
form, by the way. I mean,
gotcha.
it's
So if I remember correctly, R is supposed to be basically the x-axis, and then U is the y-axis. So R
okay.
is
Oh,
for like right,
perfect.
and then U is like up or down, I guess.
Okay,
Something like
so
that.
so they might use an L for left and D for down. Is
Mhm.
that right? Okay, so here's what we're doing. We're gonna first plot it. And thank you. That was sufficient for me to have some idea of what you're doing here. 4 right,
Mhm.
and then since you're going minus, to me that means you're going down instead of the up. Does that
Yeah.
sound reasonable?
Yeah.
Okay, so here's where you are. And if you recall in geometry, you probably learned about the unit circle. I'm gonna use radian. If you don't like that, let me know. Switch to that. But you're moving counterclockwise to get there.
Mhm.
Okay, so that's where you are on the unit circle. So polar form is and so most of your math has been in rectangular form.
Mhm.
And for rectangular form to move to a point, the D-pad, the directional pad. If you ever played video games, you've got up,
Mhm.
down, left, and right. Polar is different. You have a radius and an angle. So
Okay.
so what it is you spin and then you move out a certain amount. Like you can get to the same place by spinning and then
Mhm.
walking straight out. Does that
Gotcha.
make sense?
Yes.
And it's weird. Like, well, you're like, why would you ever do that? Well, it depends. It depends on the um, problem that you're doing. Um, so it's like you you won't see this again until maybe pre-calculus. There is a calculus course where you do this, but basically it's like this. Instead of xy, it's r theta.
Mhm.
So your radius is the hypotenuse of this triangle or this other triangle, depending on which way you look at it. So the side lengths are 4 and 4 because we don't care about the direction. We just care about the magnitude of the number,
Mhm.
basically how far are you going. So how do you find the hypotenuse when you're given two sides?
4 squared plus, well, a squared plus b squared equals c squared. So that's 16 plus 16
Right.
equals c squared.
That's right.
Then
So
that's 4 equals c.
close. You got to take the
Oh,
square
right,
root of
right.
32. Now there is a shortcut if you know the reference triangle here, but if you're not and you have to do this factor tree, you will find that you bring a 4 out, but there's root 2 left over.
Mhm.
Is that okay?
Yeah. Yeah.
Okay, because we can go over that in more detail if we need. So now that's the first part. That's your radius, 4 root 2. Okay, now your angle, there's two answers for your angle. It depends on the direction you go. If you go counterclockwise, which is what I've shown here in the black, okay, your angle is then what's called 7 pi over 4. Now, do you like the radian or do you prefer degrees?
Uh, I think my teacher usually makes me use degrees.
Use degrees? Okay.
Mhm.
So pi over 2 is 90, 180, 270. And then if you go all the way around, it's 360. You're splitting the difference between them. So that would be right in the middle, 315 degrees. Okay.
Mhm.
So that's one possible answer. But there's actually 4 answers. Okay. And here's another one. Okay. What if you go minus 45 degrees? Does that get you to the same spot?
Yes.
It does. Okay. So there's multiple answers here, and that's where you got to be really, really careful. I don't know what they're looking for here. This was 19, you said? Does,
Yes.
does this one have, answers in the back? I don't recall. Saxon does that.
Uh, there's a separate book that does
Okay.
have the answers.
Okay. So the idea there is that you maybe want to check to see if it's asking for more than one or if it just wants the first one. I'm not entirely sure what it's
Gotcha.
looking for. But is it, there's a lot that goes into this. Like, this is not a simple question. A lot of things in rotations are not as simple as, up, down, left, right. Anything I should clarify here, or is this?
Let's see. If I remember correctly, they said something about calculating the angle of theta using like sine, cosine.
I see. So you want to
I
do it
think.
that way. Yeah, that's good for me to know.
Mhm.
All right. So there in the coordinate in the unit circle here, there are 4 reference triangles. And I always call this the reference bow tie, because it literally looks like one. So when you're in quadrant 4, you want to draw this triangle. And you've already given me the sides. Now it's 4 and -4. We do have to assign direction now because we're trying to find the angle.
Okay.
And it does matter that you're going down because we're doing it this way and not through a rotation. Sorry, this is unclear. But like you said, it's sine, cosine, or tangent, right? So relative to this angle, what is the -4 and what is the 4? And your answers are adjacent, opposite, or hypotenuse. Tell me what you see here.
The adjacent is going to be the 4. The opposite will be the -4, and then the hypotenuse will be, yeah, right there.
And the hypotenuse is always positive, always positive. Now you got to decide between sine, cosine, and tangent. You could actually use any of them here because you know all 3 sides. But if you only knew the A and the B, you'd want to use tangent. So
Okay.
that's how I would tell you to do it. It's okay. It's tangent theta equals opposite over adjacent, which is -4/4. So tangent theta equals -4/4. Now, are you allowed to use a calculator for this?
Yes.
Okay, so tan inverse -1. Make sure your mode is in degrees. And now your calculator will give you -45 degrees instead of 315. There's a reason for that. That's probably not relevant right now, but you'll see that again in trigonometry. Or is this an algebra 2 trig class, or is it just algebra 2?
Well, we've done all sorts of things. I think it's just algebra
Okay.
2.
So if you take a pre-calculus class, you'll learn why it's this and not the 315, but they are both correct ultimately. So if you have a calculator handy, you're welcome to do that.
Okay.
If you want us to do 18, I'm going to need a quick refresher on what they mean in that
Yeah.
symbol, because it's not
So
something that's
if I understand correctly, it's supposed to be kind of like the opposite of 19. So it's sort of, yeah, so add, 20, 70 degrees plus. So it's
but
kind of
is it like 20 cosine 70, or is it
yeah, I think that's what they want us
plus
to do.
10
Yeah.
sine 40? I don't, or is it cosine 40?
Let's see. Okay, so it's sort of the same thing that we're doing last problem, but in reverse. So I think you'd convert 2070 first, and then get both the sine cosine of that, and then do the same thing for the 10 one, and then get the sine cosine of that, and then add them basically. So it, with including their direction. So, it might be this is down, so it'd be negative or that sort of thing. It's pretty confusing. And so that's sort of their own, I guess, system that they're.
It's their own Saxon convention. While you were very clear in what you said, I still don't understand exactly how to help you with this problem. So what I would need to help you with this is if you go back to 63 and you send over a picture, we don't have time for that, unfortunately, today. But there's a few things with Saxon that I despise, and this is one of them. They use notations that are they're just very awkward. You will not see this in college math ever. Unless you're going to a school that's 100 years old.
Yeah.
Anything real quick I can answer before we got to jump off here, before I go through the anything real, I mean, like a 24, 25, I don't know, anything in there stand out? Or
Well, okay, so 29, this is more of just rough refresher. So for estimating, let's see. Uh, I think I understand pretty well, but I just want to double check I'm doing this right. So uh, for specifically A,
Mhm.
so negative, 471, 635 by 10.5. So let's see, you'd move that, I guess, 5 places to the left. So that'd be -5 times 10 with the power of 10. Is that correct?
So you're talking about this number right here, how you would
Yeah,
estimate it?
yeah, just
Yeah,
estimating specifically.
exactly. It's -5 times 10. There's really a decimal there, like you just said. So you move it
Yeah.
1, 2, 3, 4, 5,
Okay.
like that. And then when the bases are the same, you add the exponents, so -5 times 10 to the
Mhm.
5th. And then this other one is 7 when you're going to the right. It's 7 times 10 to the -3 times 10 to the -14, like that.
Mhm.
So you get 10 times 10 to the -17.
Gotcha. Okay, that makes sense.
And then dividing, I mean,
Yeah.
we'll say it's roughly -1, 10 to the, you subtract 22,
Mhm.
roughly.
Gotcha. All right. Well,
All
that's
right.
helpful. I just wanted to kind of refresh that.